In this video, we're going to continue our discussion about slope. So we are on page 222 right now, and let's go ahead and look at this. Although a graph is a helpful visual, we might not always want to draw the graph and plot the points to figure out the slope. Let's look at the rise and the run and the coordinates to see whether we can get the values needed without a graph. Keep in mind the following. On the Cartesian coordinate system, which is just a fancy word for a graph, rise or vertical change involves the y values, and run or horizontal change involves the x values. So another way of writing slope is rise over run. Rise is the change in the y values, or this is called delta y. This little triangle is pronounced delta. You might see it in sorority or fraternity uses. It's a Greek letter. Delta y means change in math. And delta x, which is change in x. So when we're talking about the x and y, we're looking at certain points. We're looking at points x, y. When we graph a point, the rise is determined by the y values, and the run is determined by the x values. So example 3 says to find the rise and the run in the previous problem using only the coordinates. Well, before we do that, let's actually look at the formula, the way to do that. This is the top of page 223. We've got this picture here. And what's going on in this picture is that we're given 2 points, all right? So these are the points that we're given, x1, y1, and x2, y2. Now the reason that they're noted 1 and 2 is to distinguish them from each other. This is the x value of one point. This is the x value of a different or second point. This is the y value of that same first point, and this is the y value of that second point. So if we want to find the slope of this line, this is the line we're finding the slope of right here, we need to find the rise over the run. So the rise is this distance right here. Now how do we find that? Get rid of this highlighting here. In order to find that rise, we're going to take this y value and this y value, and we're going to see how much taller is this y value than this y value. And the way we do that is by subtracting the y values. Then we're going to take the x value and this x value. This x value tells you how far to the right something is. This x value tells you how far to the right something is. We're going to subtract those x values from each other to figure out the run. And then the slope is going to be, let's write this out, the slope is going to be the change in y, actually let's write it down here, it's already down here, which is y2 minus y1 over the change in x, which is the second x coordinate minus the first x coordinate. So this formula is super, super, super important. You need to memorize this formula, y2 minus y1 over x2 minus x1. And we're going to go through a couple examples. There's an example in your book here using a couple points, and you can look at that if you want. But let's go back to this number 3, which says find the rise and the run in the previous problem using only the coordinates. So we're trying to get this negative 6 over 5. So these were our points, negative 3, 4, and 2, negative 2. So let's write those down. Negative 3, 4, and what was it, 2, negative 2. And let's write down our formula. Y2 minus y1 over x2 minus x1. One of the questions students ask is, how do I know which point is x1, y1 and which one is x2, y2? Answer is, doesn't matter. So let's do it both ways. Let's pretend like this is x1, y1, and this is x2, y2, and then we'll do it a different way. Now, one thing I neglected to say over here is the letter m is often used to represent the slope. Okay, so I'm going to use m over here for slope. So the slope of this line, if I do y2 minus y1, y2 is negative 2, minus y1, which is 4, over x2 minus x1, x2 is positive 2, minus x1, which is negative 3. So you got to be careful here. Minus negative 3. Make sure you have both of those in there. Now we just do the arithmetic. Negative 2 take away 4 is negative 6. 2 take away negative 3 is the same as 2 plus 3, which is 5. And we got the answer we were expecting, negative 6/5. Now let's do it the other way. What if we made, let's do this in black. Let's see. What if we did this one as, what if we made this one x2, y2, and this one x1, y1, and we did the slope. So now we do y2 minus y1, so we do 4 minus negative 2. And on the bottom we do negative 3 minus 2. Okay, so that's going to give us 6 on the top and negative 5 on the bottom. Remember, these are the same thing. This is what we got when we did it on the graph. Negative 6 over 5 and 6 over negative 5. That's the two different ways that we got it when we did it on the graph. Kind of cool. Okay, so it doesn't matter what order you subtract these in as long as you're consistent. So if you do this one minus this one, then you have to do this one minus that one. You have to go in the same direction. And by using this formula, then you don't have to draw the graph to figure out the slope. Okay, so let's try this one. This is on the bottom of page 223. Actually, what I'd like you guys to do, this is on the bottom of page 223, and then it goes page 224, these three examples here, so there's 4 total examples. For each set of points, find the slope of the line passing through them, draw a sketch of the points and the line connecting them to help you make sense of the slope. So actually, let's do A together so I can show you what I want you to do for B, C, and D. So what I want you to do is, first thing I want you to do is find the slope using the formula. y2 minus y1 over x2 minus x1. So again, it doesn't matter the order, but what I like to do is look at these two y values and think, which way is that going to be easiest to subtract? You know, it's going to be easier to go 6 minus 1. So that's the order I'm going to do it. Then I have to go the same way with the x's, so I have to do 4 minus 1 for the bottom. So that's going to give me 5 over 3, and that's my answer. That's the slope. So then to check that answer and see if it makes sense with the graph, I want you to graph these 2 points, 1, 1, and 4, 6, over 4 up 6. Then I want you to draw the line. Okay. Then I want you to do the little stair step thing. Rise over run. So you're rising 5 and you're running 3. So that makes sense with this slope. I'd like you to do them in that order. Do the formula, get your answer, then go to the graph, plot it out, and see if you can, and see if it matches. All right, so I want you to do that for B, C, and D. Pause the video and don't start the video again until you have all 3 of those done. Alright, so for B, you should have got -1. And make sure you show all the rest of this work. If you didn't get -1, go back and look at it again. You either got 5 over -5 or -5 over 5, and you want to reduce that down. Now C and D are kind of special cases. So C, we got a slope of 0. You should have got 0 over 3 when you did your math, and that comes out to be 0. And if you look at this line, you get a horizontal line. So all lines that are horizontal will always have a slope of 0. And I remember this thinking that I can ski on this, like I can cross-country ski, and the slope is 0. As opposed to, like this, I can't ski on that. When I do the formula, I get 2 over 0, or -2 over 0, which is undefined. If you punch this into your calculator, there's no answer. And we talked earlier about how there's literally no answer to 2 divided by 0. There's no amount of zeros I can add together to get 2. And this is what those lines look like. So vertical lines have a slope that is undefined or does not exist. Undefined, does not exist. You could use either of these. All right, so we could sum up what's happening with our slopes in all these cases. Okay, so let me color code this a little bit. Let's do green for positive. So these slopes over here, these lines, that's going to have a positive slope, a positive slope, a positive slope. Anything that's kind of going in this direction, and this is getting steeper, so this is increasing positive slope. If the line is going this way, it has a negative slope. It's headed down. Negative slope, negative slope, negative slope. If the line is horizontal, the slope is 0. And lastly, if the line is vertical, the slope is undefined. Okay? So with a positive slope, then we would say that the line is increasing. Whatever it is we're looking at is increasing. If this is a bank account money or the temperature, it's increasing. If the line's going this way, then whatever it is that we're looking at, the dependent variable, is decreasing. If the slope is 0, then we have a horizontal line. There's really no change. And if we have a undefined slope, then we have a vertical line. Before we go to the next thing in the book, I'd like to talk a little bit about parallel and perpendicular lines. Let's start with parallel lines. I'm going to graph a line on here. Let's go ahead and start at the point 0, 3. And then I'm going to go, I'm going to start at the point 0, 3. And I'm going to do a slope of 3 over 2. So I'm going to go up 3 over 2 and make a dot. And up 3 over 2 and make a dot. I could also go down 3 and left 2. Down 3 and left 2. Now, I want to draw another line that's parallel to this line. Let's do that. So to get a line parallel to this line, I can start at some other point. Let's say I start at the point, I could pick any point, -1, 5. Okay, so I'm going to start at the point -1, 5. Now to make a line parallel to this, what slope am I going to need? Well, hopefully you realize I have to have the same exact slope. So if I start at this point and go up 3 over 2, I'm going to run off the board there, or down 3, -2, I'm going to get a line that's parallel to this line. So lines that have the same slope, lines with the same slope are parallel. Oops, 1 R for parallel. All right, this is an important fact that we need to remember. Lines with the same slope are parallel, or you could say parallel lines have the same slope, either way you want to say it. Now, let's talk about perpendicular lines. Perpendicular lines form a 90-degree angle with each other. All right, so perpendicular lines are going to look something like this. Those are perpendicular. You could have one going like that and one going like that, and they make a 90. So let's say I want to make a line perpendicular to this line with a slope of 3 over 2. Well, it's going to go this way. It's got to go like that somehow. So I know the slope has to be negative, right? That's decreasing, so the slope has to be negative. The tricky part is to get the slope of a perpendicular line, you're going to have to take this slope and make it negative, but you're also going to have to do the reciprocal. You're going to have to flip the rise and the run. So I'm going to have to do a slope of negative and then flip this over reciprocal 2/3. Now remember, you can apply that negative to either the numerator or the denominator and do +2 over -3. So I could pick any point on this line. It doesn't matter. Let's pick this one. And now I'm going to do this slope. So I'm going to rise -2, run +3. So I'm going to go down 2, and write 3 and make a dot. Then I'm going to go down 2 and write 3 and make another dot. Or I could go up 2, left 3. Let's do that. From here I'm going to go up 2, left 3 and make a dot. Up 2, left 3 and make a dot. So this line has a slope of negative 2/3, and it will be perpendicular to the line with a slope of 3/2. All right, so perpendicular lines have slopes that are opposite, which means one positive and one negative, and reciprocals. They have to be opposites and reciprocals. So this is, no, that's too dark. This is another important fact that we need to remember. Perpendicular lines have slopes that are opposites and reciprocals. All right, let's take a look at this last example here. I'm actually going to get you started on this one, and then I want you to finish it. All right, so I want you to finish all these parts of number 4. So this is going to tie together some things we've done. We've done patterns, remember, in the seat yourself around the tables. We seated people around tables, and we had this first configuration here. Complete the following sentence to interpret the rate of change of the number of chairs every time one table is added. We're going to get to that. Let's do the table first. Actually, I think they probably should have switched these around in the book and had you do the table first and then go back and answer A. You could look back in your work, or we could just start over. So remember, if we had one table, we could fit 4 chairs around it. If we had 2 tables, we could fit 6 chairs around it. All right, so I want you to complete this chart like we did before. And then every time one table is added, what happens to the number of chairs? I want you to fill that in there. Then I want you to answer this question. If there's a linear relationship between the tables and chairs, I want you to plot the points from the table onto the graph. Make sure you label your scale here and here and plot all your points, however they go, from the table. I want you to figure out the slope of the line. You can do that from the graph, or you could do it from the table by picking any 2 points and doing y2 minus y1 over x2 minus x1. And that's what they're asking you to do on part F. Pick 2 points from the table and find the slope by using the formula. And interpret the slope in words. So when you're interpreting it in words, you need to think about the label for these 2 things. For example, one of the first problems we did in this section was this guy. When we did the slope, we had our y value in miles and our x value in hours. So the slope is in miles per hour. And that's what you can use that same kind of idea to interpret the slope for this problem. What is the label for the y and what is the label for the x? And then you're going to have something per something. It's going to tell you how many somethings per something that you will see an increase in your table, or possibly a decrease, but this one's an increase, right? The more tables we get, the more chairs we get, so we know this is an increase. All right, so go ahead and finish up number 4, and that is it for this section of notes.